Hi, this is Sivakrishna Jonna, chemistry faculty, 12 years of teaching experience. Uh, Welcome to this Unacademy. So, Unacademy Plus. Plus subscriber. Benefits of this Plus subscription: premium content at affordable price, structured live courses, plus dedicated live doubt clearing sessions, quizzes at regular intervals for self-analysis, batches for complete preparation, test series for DPPs, full-length mocks, etc. with analysis. Use single subscription for unlimited SS. Everything under single plus subscription. So here is the subscription details. So that is, see here, best plans for EAMCET 2021 aspirants. 12 months plan, it costs around 12,375 rupees. 6 months plan, it costs around 10,125 rupees. Very useful. With this cost, you will get 3 subjects. 3 or 4 subjects. So you get 10% discount on this subscription price if you use my code. I use code JSK Live. Okay. So now in this class, I'm going to teach how to find structure of the molecules and hybridization. Okay, very useful. Regularly in JEE or NEET, any examination, many questions coming from this particular topic. Finding structure. 1 minute. Finding structure and hybridization of the molecules. Finding structure and hybridization of the molecules. Simply we can find the structure and hybridization of the molecule. So now for this you need one tabular form. If you know the tabular form, you can answer any question. So that is total number of electron pairs. Total number of electron pairs. In that, number of bond pairs. Lone pairs. How many number of lone pairs? So geometry or structure of the molecule. and total number of electron pairs and hybridization. Here only I am giving hybridization. Okay, this is the important for us, this tabular form. So if we have two electron pairs, total number of electron pairs 2. So 2 hybrid orbitals hybridization, sp hybridization. Total electron pairs 2 means sp hybridization. Okay, bond pairs 2, 0 lone pairs, structure linear. For example, if you take CO2, 2 bond pairs, BeCl2, that also geometry, linear geometry. Okay, next bond pairs, total number of electron pairs 3. Total number of electron pairs 3 means sp2 hybridization, because 3 hybrid orbitals hybridization, sp2 hybridization. Bond pairs 3 possibilities, bond pairs 3, lone pairs 0. Shape is trigonal planar. Okay, next if 2 bond pairs, 1 lone pair, geometry is angular or bent. Okay, next if there are a total electron pairs 4. 4 means total 4 hybrid orbitals hybridization is sp3 hybridization. Okay, in that 4 bond pairs, 0 lone pairs, geometry tetrahedral geometry. Next 3 bond pairs, 1 lone pair, geometry pyramidal structure, or structure is pyramidal structure. 2 bond pairs, 2 lone pairs, geometry is angular or bent or V shape, angular or bent, like inverted V. Next, if there are total electron pairs 5, hybridization, 5 hybrid orbital hybridization is sp3d hybridization. In that 5 bond pairs, 0 lone pairs, structure TBP, trigonal bipyramidal, TBP. Okay, 4 bond pairs, 1 lone pair. That structure is seesaw structure, seesaw or distorted tetrahedral. Seesaw or distorted tetrahedral. It is also called distorted tetrahedral. Okay. Next. Three bond pairs, 2 lone pairs. Shape T shape. Next page. Okay. Next, same tabular form. Number of electron pairs. 5. In that hybridation sp3 dehybridation, 5 hybrid orbitals hybridation. So in that 2 bond pairs, 3 lone pairs. So total electron pairs and hybridization. Next column, bond pairs. Next lone pairs. Geometry or structure. Okay. So 2 bond pairs, 3 lone pairs means linear geometry. Structure linear. So 6 total electron pairs, 6. See, 6 hybrid orbitals hybridization. That is sp3 d2 hybridization. sp3 d2 hybridization. In that 6 bond pairs, 0 lone pairs, geometry octahedral. Octahedral. So 5 bond pairs, 1 lone pair, geometry square pyramidal. Square pyramidal. Next 4 bond pairs, 2 lone pairs, geometry square planar. Next 7 bond pairs hybridization, total electron pairs 7. 7 hybrid orbitals hybridization sp3 d3. sp3 d3. Okay. So in that number of bond pairs, 7. 0 lone pairs. It has a pentagonal bipyramidal structure. In this 6 bond pairs, 1 lone pair. This structure is a distorted octahedral structure. Okay. So this information we need to know the geometry or structure of the molecules. So the molecules which having similar structure are called isostructural molecules. So isostructural, very important for object NEET examination. Isostructural molecules. Isostructural molecule means molecules having same structure. Molecules having same structure. Called isostructural molecules. Sometimes they will ask isostructural and isoelectronic molecules. So isoelectronic molecules means molecules having same number of unpaired electrons. So next one. Isoelectronic and isoelectronic molecules. So in isoelectronic molecules, we no need to count total number of electrons. Just you need to count the total number of valence electrons. Okay, molecules having same number of valency electrons called isoelectronic molecules. Okay, so now my intention is how to find bond pairs and lone pairs. How we will find number of bond pairs and number of lone pairs in a molecule? In a molecule, the less number of atoms and big size atom is a central atom. In a molecule, we need to know central atom and terminal atoms or surrounding atoms. Central atom, for example, NaH3. In this, N is central atom, H2O, O is central atom. So the one which is less numbers and which is big in size, that one acts as a central atom. CH4, C is the central atom. In H atoms 4, carbon atoms 1. So the less number of atoms containing molecule atom is a central atom. And similarly XeF6, in that Xe is a central atom. XeO3, in that Xe is the central atom. So now it is clear that what is the central atom. So now number of bond pairs in a molecule, number of bond pairs, very simple, number of bond pairs is equal to number of bond pairs is equal to number of the surrounding atoms. Okay, that is called our number of terminal atoms. That is number of bond pairs. Next, number of lone pairs. Number of lone pairs. Number of lone pairs is equal to, this is very important one, number of lone pairs. Number of lone pairs is equal to, first you have to know the valency electrons of the central atom. Valency electrons of the central atom. So half into valency electrons of the central atom. I am taking it as a V minus number of bonds around central atom. So how we will tell number of bonds around central atom? That point I am going to tell. For example, in case of ions, it will be half into valency electrons of the central atom plus or minus charge minus number of bonds around central atom. Okay. So number of bonds around central atom. How we will find number of bonds around central atom? This is very important. Here only your key point is present. For example, if we have halogen atom X, it can bond to other atom through one bond only. So number of bonds of the halogens, X means fluorine, chlorine, bromine, iodine. For all these, this number of bonds is equal to number of bonds formed with Ca, central atom, is equal to 1. Not only central atom, all atoms it is equal to 1. Next, if you go for OH group, OH, yes, it forms number of bonds. The central atom is equal to, it connect with a single bond, so 1. For example, if we have oxygen only double, it can form 2 bonds. So number of bonds formed the central atom is equal to 2. For example, only nitrogen is connected to central atom. So it will connect number of bonds formed with the nitrogen atom, the central atom is equal to how much? 3. So if you know this information, you can easily calculate. Now I will give some example. For example, if I take XeF6, in this, after that one more important point, that is number of hybrid orbitals. Number of hybrid orbitals is equal to number of hybrid orbitals. Number of hybrid orbitals is equal to total number of electron pairs. total number of electron pairs around Ca, that is called steric number. That one only we are calling steric number. Okay. So total number of electron pairs is nothing but total number of hybrid orbitals. You know very well about if two hybrid orbital means sp hybridization. That point I will explain wherever we need. So I am going to explain with one example XeF6. In XeF6, central atom Xe, this is central atom, and Fe is terminal atom. So number of bond pairs is equal to number of terminal atoms 6. F is a halogen. Halogen can form how many bonds? One halogen can form one bond only. 6 halogens form 6 bonds. For form 6 covalent bonds, xenon must use 6 electrons. So xenon valence electrons, xenon is 18 group, it valence electrons 8. So number of lone pairs, xenon 18 group, it valence electrons 8, half into 8. In that how many bonds it will form? Xenon with 6 fluorines, each fluorine 1 bond. 6 fluorines, 6 bond. 1 bond means 2 electrons. In that 1 electron from xenon, 1 electron from fluorine. So xenon to bond with the 6 fluorine atoms, it will use 6 electrons. Okay. So 2 by 2, that is equal to 1. 1 lone pair. Bond pairs 6, lone pair 1. So bond pair 6, lone pairs 1 means structure is distorted. Already I am given list. Structure is distorted octahedral. Now hybridization. For hybridization, you need to count these two. Number of bond pairs, number of lone pairs. We will give total number of electron pairs. That is equal to 7. 7 electron pairs hybridization is 7 hybrid orbitals hybridization. sp3d3. 1 s orbital, 3 p orbitals, 3 d orbitals. Total 7 hybrid orbitals. Containing hybridization is sp3d3. 1s, 1 plus 3 plus 3, that is equal to 7. So 7 hybrid orbitals containing hybridization is sp3d3. Okay. Next, for example, if you go with SO4 power 2 minus ion, sulfate ion. So its structure, its hybridization. What is the structure? What is the hybridization? SO4 power 2 minus. So in this central atom, sulfur, Ca. Terminal atom, oxygen. Terminal atom can form how many bonds? 2 bonds. Already I am given that information. Okay. So number of bond pairs is equal to how much? Number of bond pairs. How many central oxygen atoms are present in this formula? 4. So number of bond pairs 4. Next pairs. Number of lone pairs. Number of lone pairs we don't know. How we will calculate? Half into, in case of ions, V plus or minus C minus number of bonds around Ca, central atom. Okay, half into V, valency electrons of sulfur. Sulfur 16 group, its valency electrons 6. 6 plus, here minus charge. If minus means plus, if plus means minus. Plus for negative charge. Here negative charge. How much? 2. So plus 2 minus number of bonds around central atom. Each oxygen can form 2 bonds. There are 4 oxygens. 4 into 2, 8 bonds. Okay. So that is equal to 0 lone pairs. Now total electron pairs. That is equal to 4 plus 0, 4. So 4 hybridization, sp3. So 4 bond pairs, 0 lone pairs means structure tetrahedral structure. structure, tetrahedral structure. Okay. For example, if we take NaH4 plus, so what is the geometry of the NH4 plus? What is the hybridization also? In this, number of bond pairs is equal to 4. Number of lone pairs, how we will find number of lone pairs? Half into valency electrons of the central atom. Nitrogen valence electrons 5, positive charge means minus, how much positive charge? 1, so minus 1, 5 minus 1, plus number of bonds around the central atom. So 4 hydrogens forms 4 covalent bonds, so 4. Okay, so that is equal to 4, sorry, minus not plus, minus, so that is equal to 0. So geometry here also tetrahedral. Hybridization, total electron pairs 5. 5 hybrid orbitals hybridization is total electron pairs is equal to 4. 4 hybrid orbitals hybridization is sp3 hybridization. Okay. For example, if you take H4 FeO6 H4XeO6. Okay, it is a somewhat different. Here, what are how many surrounding atoms? For this, we need some idea about xenon. How many maximum covalent valence electrons? 8. So around this 8 covalent bonds. Okay. So terminal atoms, how many terminal atoms means this 6 only we have to take. This one we no need to take because this hydrogen can bond with the oxygen in form of OH. These 4 hydrogens will bond with the oxygen as a OH form. So in this 4 hydrogens and 4 oxygens exist as a OH. OH number of bonds 1. And 2 oxygens exist as double bond O. That point we need to remember in this compound. So in this compound H4 we can't take as a terminal atom. Oxygens only we are taking terminal atom because this hydrogen connected to oxygen. So to this xenon, to this terminal atom is only oxygens. So number of bond pairs is equal to 4. Number of lone pairs is equal to half into valency, xenon 18th group, plus how many OH groups are present, how many H atoms that are that much OH groups. So 4, that means 4 covalent bonds, 4 bonds, 8 minus 4, and 2 oxygens are bonded with double bond. Double bond means for 2 electrons, 2 into 2 4 minus 4, so 0. Number of bond pairs 6, lone pairs 0. So geometry is octahedral geometry. Hybridization, total electron pairs 6. 6 hybridization sp3d2. So now I will show you geometry of this molecule. Double bond O, OH, and OH. Okay. Next one. In this compound, for example, if I am taken IF5 or I3 minus, I am taken I3 minus. So in I3 minus, structure I2 minus, central atom I. Now number of bond pairs 2. Lone pairs formula half into valency of the central atom. Here I belongs to 17th group, 7 valence electrons. Minus means plus 1. And each iodine can form 1 bond. So with another iodine. So 2 iodine surrounding means 2 bonds. So number of bonds around the central atom 2 bonds. So 7 plus 3 10. 10 by 2 5. Sorry, it is minus, not plus. 7 minus 3, 4 divided by 2, that is equal to 2. Bond pairs 2, lone pairs 2. So geometry will be bend shape like water, bend shape. Hybridization, sp3 hybridization. Total electron pairs is equal to 4. Hybridization, sp3 hybridization. 2 bond pairs, 2 lone pairs. So its geometry is angular or bent shape. Angular or bent. Sorry, not that one. Again, I am giving that this I3 minus in this I2 minus. Okay. So central atom, this one. Number of bond pairs surrounding atoms. Bond pairs is equal to 2. Lone pairs formula half into valence electrons of the central atom. If it is negative charge, plus, you have to use plus symbol. How much negative charge? Minus 1. So plus 1. Next, minus number of bonds to this central atom. That means each iodine can form one covalent bond. 2 iodines, 2 covalent bonds. So minus 2. 8 minus 2, 6. 6 by 2, 3. Okay. So 2 bond pairs, 3 lone pairs. Total electron pairs 5. Total electron pairs 5 hybridization is sp3d hybridization. So geometry, linear geometry. Geometry, linear. So that will be like this. I power minus. Okay. Now what about odd electrons with molecules hybridization? For example, if you take CH3 dot, okay, number of bond pairs 3. Number of lone pairs is equal to half into valence electrons of the central atom. Central atom carbon. So valence electrons 4. How many bonds around the central atom? Hydrogen can form 1 bond. 3 hydrogens, 3 bonds. 4 minus 3. Okay. That is equal to 0.5. So now its hybridization. So number of lone pairs 0.5 or 0. So 0. Why I am saying it? We will approximate it as 0. Why? Because terminal hydrogen, terminal atom electronegativity, if less than 2.5, terminal atom electronegativity less than 2.5, in that case total electron pairs you will take the 0.5 as 0. If terminal atom electronegativity greater than 2.5, we will take it as 0.5, we approximate as 1. When if terminal atom electronegativity less than 2.5. Here if terminal atom electronegativity greater than 2.5. So that's why here lone pair 0, bond pairs 3, total electron pairs 3. So 3 hybrid orbitals hybridization is sp2 hybridization. Then in the same case, if I am taken CF3 dot, for this same will get, but terminal atom electronegativity value 4, which is greater than 2.5. So in this case, bond pairs 3, lone pairs 0.1, which is approximate to 1. Why? Because terminal atom electronegativity greater than 1. So total electron pairs 4. 4 hybridization sp3 hybridization. So its hybridization in CF3 dot hybridization sp3, whereas in CH3 dot hybridization is sp2. This is the difference. The same thing is applied for carbocation also. Okay. Thank you.